Okay, so now we're taking a look at some exponential equations. And if we take a look at this right here, they look pretty interesting. Okay, they look pretty interesting as far as equations are concerned because we've never really solved anything, I think, like this up to this point. So we really need to know a lot about bases and exponents and things like that. And there's more to come when you study logarithms after this. But let's go ahead and start off with a really basic example and then we'll build up. Okay, so here we have 4096 to the power x equals 8. Well, I'm going to start off by guessing, well, if this is an 8, can we write this as a power of 8? And you think about 8 to the first power is 8, 8 to the second power is 64, 8 to the third power, 8 to the fourth power, and you can stop. Because actually, 8 to the fourth power, just as a side note here, 8 to the fourth power is this 4096 that we need. So what we're going to do, instead of writing 4096, we're actually going to write 8 to the fourth power, and then we're going to keep the x. So we're going to say, okay, 8 to the fourth power times this x equals just this number, 8. Well, this right here happens to be 8 to the first power. All right, now there's a property of exponents, a property of exponential functions, I should say, that says, well, if the base is the same, then you can actually equate the exponents. And that's what we're going to do because we have an equation here. So the base is the same, they're both 8s now, and that was really the goal. Since the base is the same, we can now say, well, 4x equals 1. So if 4x equals 1, then I have a very elementary equation to solve, right? So I get x equals 1/4. Okay, so here's my answer to this first equation. Now what does it mean? It means that the fourth root of 4096, when you plug it back in, so the fourth root, kind of like the square root, but the fourth root, okay, so it's like the radical with the power 4 there. Okay, so the fourth root of 4096 is 8, and that's what this evaluates to once we've solved for x. Very similarly, let's take a look at this next one. This is 1/9 to the power x equals 729. Now, the 1/9 is kind of like a giveaway for me. I'm thinking, okay, well, maybe powers of 9 will get me here. Okay, and let's think about this for a second. Powers of 9. Well, we know that 9 to the first power is 9, 9 to the second power is 81, and it turns out that 9 to the third power, where we get 81 times 9, 9 to the third power happens to be 729. So what we're going to do is write this one as a power of 9, 9 to the third power. Now if we can only get this one to be a power of 9, and it's actually quite simple to do. So 1/9 to the x power, remember that if something is in the denominator, you can pull it back up with the law of exponents. And let me write it out for you. If I have 1 over x, for example, I can write this as x to the minus 1 power. And that's actually what we're going to do here with the 9. We're going to write it as 9 to the minus 1. And then we're going to bring the x along. So we'll leave it as minus 1x. Now again, what I said in the previous example holds. If the bases are the same, we can equate the exponents in this equation. So we can set the exponents equal to each other. So I have negative 1x equals 3. And so then, just to solve this very simple equation now, I divide both sides by negative 1. And x equals negative 3 in this case. All right, there it is. So this means that 1/9 to the power of negative 3 equals 729. And actually what happens when you plug in this negative 3 here, a negative 1 times a negative 3 is a positive 3. You get 9 to the third power, which is exactly what we have on the right side of the equation. So that's how you'd go about solving this one. Now what we're going to do is put our skills together from this one right here and this one right here to solve this very last problem, and this one is probably the most challenging, but it's actually quite easy. So we have a power, we have a base of 3 to the power 6 minus 3x, and we have 1/27. Well, what we need to ask, I think the key here is 3. And it's pretty obvious because we know 27 is divisible by 3. I can almost bet that there's a power of 3 that'll give us 1/27. All right, so I'm going to write this out. 3 to the 6 minus 3x. And let's just think about the powers of 3. I know 3 to the first is 3, 3 to the second is 9, and 3 to the third happens to be 27. Well, this is 1/27th. So that's no big issue. All we have to do is make the exponent, in that case, then negative. Because 3 to the minus 3 is like 3 to the third, 27, but the negative means kick it to the denominator, 1/27th. So there we have it. There's the trick. So now the bases are identical, 3 and 3. And now that the bases are identical, we can equate the exponents. So we're going to say 6 minus 3x equals -3. And then we solve again an elementary equation for x. So subtract 6 from both sides, we get -3x equal -9. And then finally we divide both sides by -3. And we get x equals a positive 3. Okay, so x equals a positive 3 there. And what does this mean? That means that if I put in a positive 3 here, I get 6 minus 9 in that case, which is -3. And we end up with 3 to the power -3. And that equals exactly what's on the right-hand side, 3 to the power -3, which is this 1/27. So a couple of, or 3 examples here of some basic exponential equations and how to solve them. And they're actually not too bad. You just got to know, some basic powers. So good luck.